So I'm just going to give you a quick demonstration to try and give you an intuitive sense of what's happening with residuals, standardized residuals, and studentized residuals. So I've got this example data where I've got most of the lines following the point, but this point right here, here, it's clearly an outlier and it's clearly affecting the line a little bit. If I didn't have this point, then those points up there would be much more on the line. It's never a good thing when we have got a lot of points above the line and not many below it, which is what we have up in that upper corner. So if I fit this model, this blue line is my model. If I fit that to the data and look at the residual plot, this is the residuals. This is residuals versus the actual observations y. This is not residuals versus x. This is residuals versus fitted. We do see that this point has a large residual, maybe. One of the classic problems in statistics is determining what counts as a big number. That's for a lot of statistics, that's all we're really trying to do is figure out if numbers are big or not. So it seems like an obvious point. Like if I told you that my estimate was off by 10,000 kilometers, you'd say that's a pretty big error. You missed the point by a lot. Unless I told you I was working on a cosmological scale. If we're talking about the distance between galaxies, being off by 10,000 kilometers is nothing. That's basically exact. That is a very high precision estimate. So in order to tell whether or not a number is big, we need a sense of scale. To do this, we could use the context of the problem. So if we're talking about something where negative 12 or so is a big number just by context alone, then that's great. We can call this a large residual. Otherwise, we need the variance to tell us the sense of scale. And so standardized and studentized residuals are two attempts to give us a sense of the size of a residual relative to the scale of our data. So the standardized residual just looks at, we've got all these points above and below zero. We look at the variance of these points. If you just put these numbers into a calculator and calculate the variance, you will get the internal standardization, generally just known as standardization. If instead we go through each variable or each point and we say remove this point, calculate the variance of all those points, then we remove this point. I'm off the camera there. We remove this point and then calculate the variance of all of the other ones and use that as a sense of scale. Then something a little bit more interesting happens. So when we remove this point, all of those other points are pretty close together. They're all pretty close to zero. This one is much further away from zero compared to those, so it's going to have a big effect on the variance. So if I calculate the standardized and studentized uh, residuals, these residuals have a sense of scale because they've been brought down by two separate estimates of the variance. And for most of these, they look like the Deathly Hallows symbol. The red circle is standardized. The triangles are studentized. So for most of them, standardized and studentized are about the same because the variance, when you remove one point, it's not affecting the variance too much, except for this one right above me. So there's only a red circle there. There's no triangle because I'm just in the right place to be covering it up. So this is how big the residual now. The residual now is negative 15 on the axis there. I have to look over here to read it. The studentized residual is negative 15. So the word studentized comes from the student's t-distribution. And as a general rule of thumb, student's t-distribution is pretty similar to the normal distribution. Uh, Values of around 2 or negative 2 are relatively large. Values of around 3 or negative 3 are huge. This is negative 15, and since we know what distribution this follows, we know a sense of scale, we can say things like negative 2 and 2 are large. Negative 15 is absolutely gigantic, and so this we would clearly say is an outlier. We would want to look into our data a little bit more and have a better idea of why this point is so large. Maybe we're missing a covariate, maybe there's other information in the data that we haven't noticed, maybe it's a misrecorded point. We don't know. The studentized residuals has given us an idea of how big this residual is. So just the main point here is standardized residuals just find the variance of all of our residuals and then divide each residual by the variance so that we're working in terms of standard deviations, which gives us a sense of scale. Studentized is very similar. It's just in order to calculate the variance, we remove the point that we want to standardize, calculate the variance of the remaining points, and then divide the residual that we're interested in by the variance of all the other points. And this gives us an idea of not only the scale of a particular point, but also how much it affects the variance of the rest of the points.